which makes it like 7.5 hours. And then we'd get up there, we would drive through the park, and then we would drive back. And this is back in the day when we didn't wear seat belts. You know, your seat belts were tucked so far underneath the seat that I don't think they existed any longer. And Dad had a Cadillac all the time. It was always a Cadillac with black leather seats. And leather, the heat of Arizona, do not go hand in hand because there is skin that is left on those seats because of how hot they get. But when you're driving on a leather seat and they're just going, your dad would be like, oh, I get the faster. You'd be taking corners. You'd go, wow, and sliding back and forth and hope the door holds closed. But I never wanted to go to the Grand Canyon ever again, so my wife and kids were like, I can't believe your parents ruined you. Of course, if you hear from my parents, they'll give you a different perspective. Oh, we didn't go that often. It was like 9 times I went from age 6 to 7. And I heard the same stories about New Jersey. Oh, the governor of New Jersey going yes. And you're like, what? And there's like we had AM radio. It's like, oh, yeah, I'm not getting anything. Because, AM radio, this is back in the old days. Needless to say, I was able to hang out with some of my closest friends on Tuesday evening. And I tell you what, I think I can tell a tall tale. You should hear the tall tales once my buddies are there. I think some of these tall tales are getting to a point that we're going to become bulletproof. We're going to be able to see through walls. We're flying. Like, you're going ready to reminisce some old story. Like, I don't think it really happened. No, it really did. Okay. Remember when I was the all-state receiver for football? You didn't even play football. So, funny stuff. All right, so we are coming down to the end of our semester, which is great. Today we're going to focus on 5.3. We'll finish it up tomorrow, 5.4. And then we have the review and then the chapter test. And then we start our semester exam review. I think that's what we have planned. So here is the perspective for all of you. I will mark off the 5.3 homework tonight that I will give you tonight, tomorrow. I will mark off the 5.4 homework I give you tomorrow night. And I will mark off the review. Cool? Yeah, Johnny? Do you know what our final's going to be like? Yeah, it's going to be on paper. It's a math problem, probably a proof or two. Yeah, that's starting Friday. Probably Friday. I start getting the reviews. Hey, oh, perfect. I'll get it in there for you. All right. So, the following people owe me something. Oh, thank you as well. Oh, too many I gave you guys. Sawyer, you owe me the chapter 4 test. I have it here. So you need to try and figure that out of when you will take it with me. Cool? You know where I'm at, so you can do it during my class. If you have an off period and I have a class, so what? Come on in. Lucas, you have the quiz 4.4 through 4.6 you owe me. No. It was worth a try, but no. And then you'll tell me, well, I'm not going to listen to the lecture. Well, that's your prerogative. Right? All right. Perpendicular bisectors. So we talked about the centroid, which was the center of mass of the triangle, and you found the centroid by cutting the segment into half, correct? And then you connect the median to the opposite vertice, right? And then we talked about, what was the next thing we talked about? It's called like the orthocenter, and it was the what? The height of the triangle. And all the heights of the triangle would all meet in the center. Now we're going to talk about what happens to the perpendicular bisector and where they will meet. Okay? Now, in order to find the median, the middle, versus the perpendicular bisector, it's very similar mathematically, and as far as this goes. But we're not going to connect the perpendicular bisector back to the opposite vertice. We're just going to draw it straight out. So let's go to the end here. I just want to talk about how that perpendicular bisector could be found if I were to have a segment. Okay, so let's say there's an endpoint on that segment. I want to find the perpendicular bisector. It's been a while since we had found a perpendicular bisector with a compass. Does anyone recall how we had done this?
All right, so you
I what?
So you put the point on one end.
Okay, so I'll put the point on one end.
And you make like a swoop that's bigger than half.
Yes, so I want to open this up to be larger than halfway. It could be the whole way, it could be beyond the whole way, but it's got to be more than halfway. Okay, so I'll open up a little bit more. So we'll do this, and what I'll do, I will swing an arc. And then what do I do once I've swung that arc? Switch it. So I'm going to bring this, keep the compass the same size. I'm going to flip this over. Keep the compass the same size, put the point at the opposite end, and swing another arc. By me doing that, I create two arcs crossing. Two arcs crossing establishes a point. Agreed? So I have a point here, and I have a point here. And if I connect the points using a straight edge, let's do, I don't know, that corner sounds pretty. All right, go there. So this is the perpendicular bisector. So the perpendicular bisector forms 490-degree angles with the segment we're talking about. Agreed? So this forms 90, 90, 90, and 90. And what can you tell me about the distance from here to here and here? Yeah, this is the same distance as this. Okay, so that's how you would find the perpendicular bisector. So the perpendicular bisector cuts the segment into two equal parts, and then it makes 490-degree angles. Okay, so that's kind of the math that we're going to go with, and I'm going to go backwards here. All right, so develop and understand the properties of perpendicular bisectors of triangle sides. What two things do you predict will be true about perpendicular bisectors? Would you think that all three perpendicular bisectors will intersect each other as far as lines go? Okay, and they will they will create 490-degree angles on each side. They will cut the segment into two parts. So those are just some predictions you can make. Okay, so how many perpendicular bisectors can you identify? So from A to M, from M to B, we have a tick mark here. We have a tick mark here. That tells us that those segments are the same. And this actually creates all of these 90s. So there's a lot of things that we could say is the perpendicular bisector. Okay, we could say that line segment CD is the perpendicular bisector to AB. We could say SD segment is perpendicular. We could say line SR. We could say line SD, line SC. They're all the perpendicular bisector of line segment AB. So there's a lot of perpendicular bisectors. You could say it by segment, a whole line. You could say that ray D to S would be a perpendicular bisector. It's perpendicular, forms a 90-degree angle, cuts the segment into two equal parts. Yep. Good? Yep. Can I move on?
Yep.
Woo! Okay. All right, now, I'm just going to show you how this is going to work. I'm not going to pull out the compass because to me, if it's pretty painful for me to use the compass up here, it might be to you going, dude, it's like watching someone type and they can't find the S key. You're like, S! You're like, okay.
That's not relatable.
Maybe not for you, pal.
Oh,
Over.
God.
All right, so, ready? So, swing an arc, swing an arc, swing an arc, swing an arc. Connect them. Good so far?
Yeah.
Yay?
You just draw
I did you see me have the compass out for some of those arcs? Okay.
That was awesome. Good job.
All right, so That's that one. Now this one, I'm going to swing an arc. Did you see that? And then way down here is another arc. Okay? I do. And let's just pretend I cut that into 2 equal parts. And then my last perpendicular bisector is in red. So we did that, and we're going to do this one. So swing an arc. Okay? Yeah, talk to me.
Do you know 24 karat magic?
No.
You should sing it, though.
Not there.
Do it.
All right, so basically this would be the perpendicular bisectors. What do you suppose I might have done wrong here, other than I didn't do it by hand? Or I did it by freehand, not by compass. The thing is, the intersection of these 3 lines should be 1 point. Do you want to know how you make 1 point? See that point there?
No, it's
So, if I had indeed swung 3 perpendicular bisectors of this particular triangle, all 3 of the perpendicular bisectors would intersect, okay? And they all 3 intersect at that point. Why did I make the point big? Because my freehand drawing was bad.
I feel like you did well.
Thank you. I should get a ribbon or something, or at least a certificate of completion. Make me feel better.
Oh, one of those participation trophies?
Yeah.
Yeah. Those things.
All right.
I hate thousands.
Carefully connect each vertex to the point of concurrency. Use the edge of the piece of paper to compare the lengths of these segments within the triangle. What conjecture can you make here? All right. So they want us to do this. Carefully connect here to here, here to here, and here to here. We carefully connected. Did everyone see us connect?
Oh yeah.
Okay, so that's what we were doing there. So that's all we did. What conjecture can we make? Okay, this could be proven as a theorem. I'll get my notes in place.
The orange.
The what?
The orange.
The perpendicular bisectors of a triangle intersect at a point that is equidistant. This is where math people thought they were good with spelling. We're going to put equal and distance together, and it's become equidistant. From the three vertices of the triangle. Okay? So, you have your perpendicular bisector, where all 3 of those perpendicular bisectors intersect within your drawing. If you go from the vertice of each, so each of the corners of the triangle, the 3 corners, the distance is the exact same. So the perpendicular bisector, so if I had found this was where all my perpendicular bisectors had intersected, the distance here, and the distance here are all the exact same. Good so far? Making sense? All right. Can I move on? Woo! All right. Oh, we can go here. Okay. Do we trust it? Talking to it. What's going on? Jumping around and back, loading.
During the walk.
All right. All right. So, however I move this, so this is of this triangle, totally skinny triangle. The perpendicular bisectors happen outside, agree? The distance from A to this point, C to this point, and R to this point are the exact same. Okay? And no matter how you move it around, it's going to be the same idea, including if it happens inside here. If I go from A to this point, C to this point, B to this point, it's identical every time. Make sense? So the perpendicular bisectors intersect here. Those distances are all the same. It's just kind of neat. So yeah. So okay, so the perpendicular bisector is a line segment ray or line drawn through the side of a triangle. Yeah, buddy. We're not adding heat for you in chemistry. That's triangle.
A or
Midpoint. All right, so perpendicular bisector, line segment, ray, or line drawn through the side of a triangle at the midpoint and perpendicular to the side. Okay, the circumcenter is the point. Okay, so the circumcenter is the point where the perpendicular bisectors of the triangle meet. By our diagram, they can meet outside of it or inside of it. The circumcenter is equidistant from all of the vertices of the triangle that you're talking about, meaning it's the same distance. Sound good so far? Yep. And again, I can't give you any really neat analogies. You know, the circumcenter is not as cool as the centroid. But can I move on? Which of the following statements would always be true? All triangles have 3 perpendicular bisectors. I agree with that. That's got to be true. Perpendicular bisector passes through the angle opposite of the side it passes through. Sometimes. That's as best we can state that for. A perpendicular bisector divides one side into 2 congruent segments. True. And then the perpendicular bisectors of a triangle intersect in a point in the interior of a triangle. Sometimes. Okay? All right. Perpendicular bisector of triangle TRE have been constructed below. Identify the midpoints of each side. Well, this is the midpoint of side TR. This is the midpoint of side RE. This is the midpoint of side TE. Okay? Identify the circumcenter. So this right here is the circumcenter. And so now things that we should know is this distance here, and this distance here are all the exact same distance. And then let's see if we can identify what this means. If they told us that EC, so from E to C was 12, find RC. Oh, 12. And TC is 12.
So,
yeah.
If that wasn't approved, what would you write for the reason?
Definition of circumcenter.
Oh,
Definition of CC church. All right. Yeah.
it was
So close. I heard it's a great game.
Nah, I was trying.
You were like I was, but I tried back in Arizona.
it's weird to be there.
I was driving real fast, so I was trying to get there. I broke a speed limit or two in Mexico. Just be careful, please. All right. Let's see. The perpendicular bisectors are shown. Identify them. Well, I would say YO, yo, and yeet or yite. And what's the other one? Yeah. Yeah, boy. Oh yeah, I'm sorry. You're right. So all of these are that. The circumcenter, you're so right. I'm so sorry. The circumcenter of this is point Y. So the circumcenter is point Y. And then find HY. Find HY. Find H to Y. So we want to find that. So we know that distance has to be equal to this distance. That distance is 15, so that has to be 15. We have to know that distance is the same, so that's also 15. So that's how we would find all of those. We just need to find HY, so we found two others. Oh well, one other. Moving on. What two facts can we use in a proof if we are given that a segment is a perpendicular bisector? What do you think? So you have four right angles, and if we had two facts, if you knew that these segments, you're going to have congruence, you'll have three congruent segments from the vertice to the circumcenter. They will always be the same. So to prove that a segment is an angle or perpendicular bisector, we must prove which two facts? We must prove that we have the right angles. Okay? If you prove you have one right angle where you have a linear pair, that automatically tells you have four right angles there. Okay? And then if you could show that your segments are congruent, if you could show both of those things that are above, we can prove that we have a perpendicular bisector. Look. Eugene, you need to go out and see your dean. All right. So I don't want to. I'm not going to put all the statements here, or the givens. So I know that AB is congruent to BC. Okay, written down given. Still with me? Yeah. Okay, so that takes care of this. I know that AD and CD are congruent. Okay. So totally we could do a reflexive. Let's see what we're trying to prove. We're trying to prove that BD is the perpendicular bisector of AC.
Alright, I got this.
You got it?
So you do reflexive, right? Then you prove that the angles BEA are congruent to BEC. Since they're congruent and they're also supplementary, they're congruent. They're right angles and they're congruent, proving that it's a. And then you also have to prove that EA is congruent to EC, proving that it's a perpendicular bisector. What?
No.
I got it.
He's got
Say
a walk.
BE is reflexive, and then you can
D.
No.
Just BE?
If you say BE is reflexive,
Then you can say BD, and then you can do the triangle. Goals. The
just
triangle.
say BE. And then figure out AB is congruent to CBE.
How?
And then you
Let's
can
go.
do
Let's go
side
BDD.
by side.
BD. BD and BD.
No, you can
AC
do
and
side
AC.
by side and prove that the triangle right here, and then you're from there. It's so much
Either
easier.
one of those you could state with reflexive. Agreed? BD, BD, AC, AC.
Yep.
Doesn't matter which one. If you've done that, then you could easily go in and say that triangle ABD is congruent to triangle ABD to CBD. And that's going to be a side, side, side. No matter which way you had proven those, that's going to work. Okay? I mean, I would say this is more the correct one that you want to assume right here. And that's going to allow you to state that this segment here is congruent to itself. That does not say that BE and ED are the same. But from there, you could go ahead and state that AE is congruent to EC. I've already proven side, 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 so now I can say CPCTC. Agreed? So that tells me that this and this are the same. And from there, we could go ahead and state that angle AEB is congruent to angle AEB to CEB. And that's another CPCTC. So now I've proven this angle are congruent. Congruent angles of a linear pair are supplementary. So I could then say that angle AEB and angle CEB equal 90 degrees because congruent angles of supplementary / linear pair equal 90 degrees, something like that. And then that will tell you that BD is the perpendicular bisector of AC. And the reason you can state that is you could state all kinds of things. You say linear pair, supplementary angles, 4 90-degree angles, something like that. Any of that's going to be fine for me. Okay? Did you quit ripping up your paper?
It was erasing.
Bad kid. Playing with matches again. Just keep them lighter this time. Alright, moving on. In the steps that were approved, what did we prove about AB and CB? A, B, and CB. A, B, and CB. We proved that the point is equidistant. Point B is equidistant from it. From AC. What did we prove about AD? And then that's equidistant. And then, so being that all of this was proven or given in the proof, that's going to mean that BD is the perpendicular bisector of AC. Giddy. I don't know why that screen is up there, but I'll deal with it. Don, it's your fault. I was up there. Apologize. All right. Whenever you have 2 points equidistant, from the endpoints of a segment, you can always prove that they determine the perpendicular bisector. Bisector, I don't know what that is. That's just extra. Of the segment. Stand up then. All right. Let's see what we got here. Okay. Theorem 5.3 would state if 2 points are equidistant from the endpoints of a segment, then they determine the perpendicular bisector of the segment. 2 points equidistant from two endpoints is perpendicular bisector.
What were the last two points for the last slide? I can't see anything. I can't even read that.
If you have 2 points equidistant from the endpoints, they always prove that to determine the perpendicular bisector of the segment. Perpendicular bisector. Shirley. Can I call you Shirley?
Oh yeah.
Okay.
Yeah, I can't see anything, so
Why can't you see anything? Close your glasses.
I hate my life. My friends are so
He
dumb.
actually can't see. I've tried his glasses.
Yeah, his glasses, it is so hard to see. My vision is bad, and his vision is even worse.
Why does this happen?
Why'd you take Don's glasses?
Sawyer did it.
What?
Like Sawyer?
Thanks, glasses.
I hate my life.
Alright. What is given in the diagram? Things given in the diagram. AB is congruent to BC. AD is congruent to CD. Those are givens. Okay. Wait, where did this one go? There it goes. What can we deduct? We can deduct that BD
Congruent to itself.
Gosh, give him his glasses back.
It's so bad. Like, you can't see here. Try.
You gotta wear glasses, man.
You know, he actually
It's
can't
dark.
see.
I got
trifocals, pal.
Put them on. Like,
Oh!
Can we get back to the lesson?
for real? I'm waiting.
I'm sorry someone took your glasses. That's just not fair.
God's
I have a
sake.
broken heart.
It's just not fair.
God's sake.
Alright, so being we have these are congruent, we can deduct that BD is the perpendicular bisector of AC. That's our big conclusion there.
Because the two segments.
Will the converse be true? CM is the perpendicular bisector of AB. So can we state, so if we had this, we drew this in place,
Auxiliary lines. Oh, each held postulate.
could we draw in other points? Could we state that this is congruent to this, if that is this congruent to this, and then is this congruent to this? So any point on the perpendicular bisector, so if this is the perpendicular bisector here, any point on it, we can create a true. So we can create another point, draw those, what are those lines called that don't,
Auxiliary lines.
do we know what?
Now that he can see.
Are they auxiliary?
Auxiliary.
Okay.
Oh,
Almost done, almost done. Woo! Rock and rolling.
thank the Lord.
Oh man, I would love to hear myself talk more. Okay, point on perpendicular bisector is equidistant from the endpoints. Sweet. Okay, if a point is on the perpendicular bisector of a segment,
And it is
then it is equidistant
from the
from the endpoints
of the segment.
of the segment. Sawyer, what are you doing?
being number 1.
What?
Kids.
You're being bad, mister. Don't make me call mom and dad and say they have to come sit next to you during my class. Because
Oh,
Sawyer
yes,
would
you
start picking on him.
No, let's not have
Yeah.
I had one parent take me up on that at back to school night. It's like, any parents want to come to my class? I had to ask the parent to leave.
No.
They were screwing around more than their kid. I'm like, no wonder what's wrong
Hey,
with
this
you.
is pretty neat, guys. It's
Parents turn around, oh, so how's your mom doing? It's like, look, I'm up here teaching. Oh, that's okay. So let me finish this conversation. No. All right. Shh. Can this and this be considered to be the same thing?
Yeah.
Equal. Yep. Could I do there? Do here?
Yeah.
Is that considered to be equal?
Yeah, hey.
And then any one of these as I go down, here to here, I can go here to here, I can go here to here.
Oh no, you're gonna keep doing it. Oh no. 5, 6. 2, 3, 4, 5, 6. There you go.
So that's a whole lot you could go and start justifying if you do perpendicular bisector. Yeah.
Is that because AM equals MB?
I'm sorry, say that one more time.
Is that because AM equals MB?
Yes. And that justify, and then you have the perpendicular, so that justifies that you're talking about the perpendicular bisector. So you have all of these equidistant segments that you can do along the perpendicular bisector from the endpoints. 2 proofs in time. You ready? All right. Center O and center OC, or center C. Circle O, circle C. Those are our givens. Okay? OC is perpendicular bisector AB. All right. Can I state, so let's just say I have my givens. We know what our centers are. Can I say that OA is congruent to OB and Y?
Definition
Oh,
of
and-
radii.
Radii. So right here and here, those are congruent. I could also state that CB is congruent to CA. That's radii again of a different circle. So let's do this.
Equidistant.
Okay. So then that would mean what?
They're both equidistant from point A and point B.
So that would state right away that OC is perpendicular bisector to AB. And then the reason this works is you have 2 points equidistant. These 2 points are equidistant from here, and these 2 points are equidistant from here. So you have 2 points equidistant.
Can't you just say that?
2 endpoints. And we will call this the theorem of Don.
Oh yeah, I'm down. That's actually. Can I actually write that on a test?
I'm with you.
Oh,
Alright,
just
like,
no.
actually.
I'll take yours on that. Everyone else though, no.
No,
All
we
right.
can't.
Okay.
Already incorporated into my mind.
All right. Last proof. Here we go. RS is perpendicular bisector PQ. RS is perpendicular bisector PQ. So we know that this distance is equal to this distance, yes? So find PR. Find P to R. So I know that 6x is equal to 8x minus 9. Yay?
Yay.
Subtract 8x, so I get 2x, negative 2x equals negative 9. So x equals positive 9 over 2, which is 4.5. With me so far? Is the problem done? No. Let's plug 4.5 in right there, so I get 8 times 4.5 minus 9. What's 8 times 4.5?
It's
Oh, shoot.
hold on, 27. I think.
Well, if I double this, that's 9. So it becomes 4 times 9, which is 36 minus 9, which is 27. Yeah, that was it. Good. And that would also be 27. Woo!
Are we done?
Yeah, baby.
We
So,
finally finished notes one time.
yeah. All right. So, your assignment that I will indeed mark off tomorrow.
It's true, someone took my blueberries.
You have blueberries?
Yeah, someone took my blueberries.
What are you bringing blueberries to school
I'm
for?
stressed.
Stressed?
You don't know where you're
Oh my god. Never mind. I can hold myself.
You played yourself so hard.
So this is assignment. Uh-oh. Uh-oh. You weren't here today, were you? I missed you.
He is, so Dr. Oster, he knows Dr. Oster had kids pass out during how gross it was. His name's Drew Powell. He's
He is going. There's going to be kids that are like crying. Good seeing you. All right, so guys and girls, your assignment for this evening is 97 proofs. Is
97.
worksheet 5.3. This will be marked off tomorrow. This is one of your final homeworks that are going into the grade book. So you wanted to make sure you do it.
This semester, the whole year.
This semester.
Mr. Stroud, what worksheets were due on last Tuesday?
I did not collect anything. So
Okay.
if you didn't do it, you're fine.
So 5.1 and 5.2 you never collected.
I never collected. I don't